Hello everyone. Today's topic of discussion is about dehydration of different food materials. Drying has been practiced from ancient times as a food preservation technique by mankind. It is one of the easily available and cheapest techniques adopted for shelf life extension of foods. Still, it is an imperative process in the rustic life where sun drying of different food materials like meat, fish, seasonal fruits and vegetables is done. Drying or dehydration is defined as the removal of water by evaporation from a food substance in order to obtain a solid product adequately low in water content for shelf life extension. After going through this session, you will be able to explicate on the concepts involved in dehydration and interpret the dehydrated products. Let us introduce to drying. The mechanism of dehydration is a slow process involving the transport of heat to the food material, causing the movement of water from the food simultaneously, thereby reducing the water activity, the food form with respect to weight and volume, rendering crispiness and other desirable features to the product. Dehydrated foods are convenient and can be easily packed, stored and transported. The medium of drying is air in most dehydration processes. In mechanical drying, the factors affecting the rate of drying are airflow rate, temperature, energy consumed, type and design of the dryer and the rate of drying. Depending on the moisture content of the raw material used, the process optimization is done within a dryer. For instance, a multi-stage dryer is employed for drying fruits or vegetables containing a high moisture content. Initially, a high temperature and increased air velocity is maintained in the first stage of drying and vice versa at the final stage of drying. Let us see the differences between sun drying and solar drying. In sun drying, the sun's radiations are used directly onto the foods for removal of moisture. Almost all dry fruits like apricots, raisins, figs, etc. are produced worldwide using sun drying. Fish, grains and vegetables are also sun dried, and the solar drying refers to drying system that utilizes a convective dryer that heats up the air with the solar energy, which in turn is used to dry the products. Talking about the preliminary treatments, blanching is the process of dipping the foods in hot water followed by immediate immersion in cold water. This prevents enzymatic activity and microbial growth in fruits and vegetables. For tough or hard skins, a preliminary dipping in hot solution of potassium carbonate promotes easy peeling. Discoloration of fruits and vegetables can be avoided by immersing in ascorbic acid or citric acid solutions. This is skipped in the case of pungent vegetables to retain their characteristic pungency. The US is a leading producer of dry fruits. Export trade dealers are countries like Greece, Middle East countries like Iran, Turkey, Portugal, Iraq, Algeria, Australia and South Africa. The Middle East countries are the chief manufacturers of figs and dates. The major dry fruits produced worldwide include raisins, prunes and figs. Sun drying is widely practiced for drying of fruits that always yield products of superior quality. Cut fruits like peaches, prunes, apricots and apples are also produced by solar drying or artificial drying. However, limitations of solar drying due to unpredictable weather conditions and the problem of sustaining hygienic surroundings are overcome by adapting to dry, blanch and dry method. This method will be discussed later. The first preliminary treatment after blanching is sulfiting. Mechanical or artificial drying of fruits allied with sulfiting yields quality products. Sun drying does not essentially require sulfiting. Instead, if applied, could contribute to extended shelf life of dry fruits with excellent quality retention. A sulfuring shed is constructed away from the processing unit on the raw materials. Sulfiting process is done on the fruits that are spread uniformly in perforated trays and stacked in trolleys that are sent inside the sulfuring area of the shed. Natural or forced fan ventilation is provided through the roof. Sulfur concentrations in the final product range from 1500 to 2000 ppm. Sulfiting is avoided in fruits that are dried naturally, as in the case of few varieties of raisins. Discussing the processing aspects, in fruit processing, artificial drying in conveyor band or tunnel dryers are applied to currants and peaches only. For fruits like apricots, apple rings, natural raisins, pears, the dry, blanch and dry method is employed. Discussing about the dehydration of apples, the first step begins with washing. Reception of apples from the fields is done in crates or boxes, which are further subjected to thorough washing in water tanks or water sprays to eliminate field residues and pesticides. The next step is grading, where accurate grading of apples is necessary to eliminate the risk of waste in peeling, coring and trimming operations. The apples are number graded according to the ratio of the diameter per kilogram weighed. Next step is peeling and coring by following the manual method, mechanical or flash peeling with steam. These methods are commonly employed for peeling of apples. Medium scale processing plants make use of either flash steam peeling or mechanical peeling. A steam peeler comprises of steam chamber operating at 17 to 18 atmospheric pressure and a minimum exposure time of 15 seconds continued by exposure to potential water jets that remove the skin. Mechanical peeling has the highest efficiency of 75%. The peeled apples are conveyed to an inspection cum trimming conveyor. The next step is sulfiting, where the trimmed apples are immersed in 1.5% sulfite solution in order to avoid browning and oxidation by using fluming technique. After sulfiting, the fruit pieces are conveyed to the cutting machines. In the cutting machine, the size of the cut apples depend on the type of the desired final product. A cutter with radial knives chops the apples according to the requirement. Next step is resulfiting, where a final dip of sulfite is given to attain the residual levels of 1500 ppm in the cut apples. This is followed by a step of dewatering, where excess water to prevent leaching losses that leads to reduction in total sugars and soluble constituents. The final step is drying, which is done in conveyor band dryers or tunnel dryers at an initial temperature of 70 degrees Celsius in entry zone and which is reduced to 50 degrees Celsius in the exit zone. Final moisture content ranges from 20 to 22% in dry rings and 4% in dry flakes that could be stored for a period of 7 to 8 months in cold rooms at 85 to 90% relative humidity. Let us discuss the flow chart, which involves the various steps in apple dehydration. The first step is feeding, followed by washing. Then it goes for sorting and grading. The sorted and graded apples go for peeling and coring, followed by trimming. This is continued with sulfiting treatment, followed by cutting or sizing, then giving a step of resulfiting, followed by dehydration. Then it goes for final quality grading, followed by packing, and the final step is transportation and shipping. The next will be the dehydration of apricots. Feeding and sulfiting will be the preliminary steps involved. A bulk feeder conveys the apricots by lifting them into a sulfiting tank, containing 2 to 3% sodium metabisulfite and 0.5% citric acid solution for 5 to 10 minutes. Next step is dewatering and pitting, where a stainless steel screen is used to remove the excess water, which is further fed into a manually inspected conveyor belt where pitting is carried out. The next step of resulfiting elevates the sulfur levels in apricots in a sulfiting tank for 1 to 1.5 minutes, continued by dewatering. Next comes the preliminary drying, where initial drying is done out on stainless meshed plates at 71 degrees centigrade, where the cut portion is faced upwards. A steam exposure for 4 to 5 minutes is done in a steam blancher, after which the trays are relocated to a secondary dryer when the cut portion is turned towards mechanically and dried at 65 degrees Celsius. This step is followed by drying, where the final drying is carried out in bins at 49 to 50 degrees Celsius to equilibrate the moisture in the dried apricots at 20 to 22%. Final quality grading and packing is done on conveyors within built permanent magnets and metal detectors. Let us discuss the flow chart for apricot dehydration. The first step involves the first step from the feed inlet flowing towards sulfur and citric acid treatment, followed by pitting, then dipping the half fruits in sulfur and citric acid, followed by preliminary drying, blanching, final drying, quality grading and packing. The effect of dehydration on fruits will be discussed as follows. The apricots respond well to dehydration by sun drying by yielding an intense lucid color than the mechanical drying. When the blanching temperature was reduced to 100 degrees Celsius, it results in more than half of the moisture removal in initial drying itself. At a blanching temperature of 92 degrees Celsius in raisins, highest elimination of splitting was observed as it occurred in a 100 degrees Celsius blanch. Let us come to the discussion on dehydration of vegetables. The dehydration of vegetables require different equipments and layouts depending on the type of the vegetable. Constant switchover of products often results in change of layout arrangements, turning the process expensive. Knowledge on seasonal vegetables and climatic conditions that determines market demand would make a profitable business. Vegetable processing steps vary from region to region and climatic conditions. The dehydration of few common vegetables can be discussed in this topic. Let us discuss about the dehydration of bell peppers, where the first step involved is feeding, then it followed by a double flood washing, then dividing and deseeding. Deseeding is a step where the seeds are removed. Then it is continued by a double flood wash with a quality inspection, followed by size reduction, sulfur treatment, dehydration, conditioning, screening and final inspection, followed by packing and transportation. Talking about peppers, they are processed usually in unripe green color or in ripened red color that dominate the market. The first step of feeding and washing, where the bell peppers are arrived from the fields in crates. A bulk feeder receives the peppers, are lifted into a double flood washer, possessing a compressed air system to remove the adhering dirt and debris. Dividing and deseeding involves splitting or dividing of peppers, which is preceded by inspection, after which the peppers are passed for seed removal. The seeds are removed by a flood washer and forwarded to the examination zone for the hand removal of any adhering seeds. This is followed by cutting, where the peppers are then sent to a mechanical cutter that chops the peppers into flakes or dices. In the sulfiting step, the flaked peppers are subjected to a treatment with the solution of sodium metabisulfite imbibing a residual concentration of 1250 ppm in the final product, followed by dewatering. The next step is drying and conditioning, where preliminary drying is performed at a temperature of 85 degrees Celsius, continued by a secondary drying at 50 degrees Celsius. Conditioning is done in metal dryers attaining a final moisture content of 6% to 7%. This is followed by the final inspection, where the dried flakes are sent to a vibratory conveyor scheme for the separation of the fines. At a time, 60 to 90 kg of dried products can be graded in 1 hour per belt at a speed of 4 to 5 meters per minute. Let us discuss about the dehydration of garlics. The first step being feeding, followed by bulb cracking and opening. This is followed by screening and separation by air aspiration. This is also followed by flood washing, where water is removed and then it goes for grading and inspection. Size reduction is the next step, followed by dehydration, then screening and separating through air aspiration, and this is followed by pulverization and kibbling. The inspection of milled garlic powder of 250 microns followed by packing is the final step in garlic dehydration. The first step, where the whole garlic containing 20 to 36 bulbs is cracked into individual cloves by passing through rubber rolls that splits only the cloves without compressing or damaging them. Aspiration is employed to remove the feathery peel, which is separated by flood washing. This step is followed by dewatering and inspection, continued by slicing in a mechanical slicer and loaded in a flow dryer for mechanical drying at 70 degrees Celsius, that is reduced to 50 degrees Celsius at the outlet. The final moisture content of 5% is maintained in the product. In aspiration and kibbling, the still remaining skin is removed by screening followed by air aspiration. Quality of the dried cloves is maintained by further scrutiny for adhering skin. In the step of kibbling, a turbomull is enclosed with 250 micron screen, which is used to grind or kibble the garlic cloves, where a final moisture content of 4% is attained. Let us see about the dehydration of potatoes. Potatoes are really worldwide liked product, where the potato products are manufactured by employing single drum dryer for nearly 70 to 80 years. Potato products on reconstitution with hot water results in 98% efficiency, nearing the natural flavor and texture. The drying process aims at reducing the breakdown of starch cells in order to reduce the fraction of amylose. Let us discuss about the suitability of potatoes for slice making. The important requisites for potatoes that are selected for slicing are white colored flesh, increased solids content, reduced enzymatic browning after cooking, reducing sugars contents below 2%, structure and shape retention after reconstitution. The steps involved in dehydration of potatoes include feeding, removal of dry dirt and cleaning, followed by washing and stone removal. The skin is peeled and then washed and subjected to inspection and trimming. Then the potatoes are sliced, followed by hot water and steam cooking treatment, and then they are cooled. The addition of additives and drying takes place, followed by size reduction into flakes. The final quality checking is followed by addition of antioxidants and primary modified atmospheric packaging with nitrogen flushing. The secondary packaging in sacks with polymer lining is the final step, whereafter the potatoes are exported and shipped. The first step involves the receiving and cleaning of potatoes, where they are fed into the receiving line, from where they are sent to dry cleaning for the removal of dirt and adhering sand. This step is followed by peeling and washing. Live peeling or steam peeling are the steps followed for potato slicing. Then they are water washed mechanically for elimination of surface starch. Next step includes trimming and slicing. Meticulous monitoring is practiced after washing in order to get rid of discolored areas and ice. Then the tubers are passed onto a slicer for slabbing them into 20 mm slices. Cooking and mashing of potatoes are done in hot water at 71 degrees Celsius to 72 degrees Celsius. Cold water circulation is done to reduce the temperature. Further cooking in a continuous atmospheric steam cooker is also done. Then mashing is done by passing through rolls with holes softly on the product, and the product is discharged at the opposite end. In additives addition, improved product qualities require addition of certain food additives that results in appreciable firmness, color and mouthfeel. Antioxidants are also used for flavor retention. This is followed by drying, where the potatoes are converted to flake forms, and this is passed onto a scrutiny on a conveyor belt. Final monitoring is performed on magnetic detectors and other metal detectors. Packaging involves the primary packaging, where nitrogen is flushed into the packs in smaller quantities, whereas bulk packaging is done in 12 to 15 kilogram sacks with polyethylene lining or nitrogen flushed airtight drum. Let us discuss about the dehydration of meat and poultry. The mandates for setting up a meat processing plant would include a separate operating plant to be constructed to maintain hygienic standards. Consultation with health authorities is a must in order to follow all the bylaws involved. Sufficient cold storage is essential for on-time production. Freezers with large capacity to store additional meat during seasonal sale. Strict raw material specification standards should be practiced to ensure uniform quality. Proper waste disposal facilities are also to be maintained. Prerequisites for raw materials would include the meat from goat, cow or poultry is brought in a cleaned, eviscerated and deboned condition in fresh or frozen forms. The first product being chicken granules, where they are cleaned and eviscerated poultry is completely thawed and pressure cooked in autoclaves, where they are emptied into punched steel containers at 5.5 atmospheric pressure until bones and flesh separate freely. The collected fat is used as a soup ingredient. The bouillon is also concentrated and added to processed flesh in the final stages. The fleshing and deboning operation is done on a deboning table, where the flesh and the bones are removed and filled into sterilizing trays. After meticulous examination for the presence of bones, the flesh is transferred to a slow-moving bladed steam-jacketed mixer, and the addition of recovered bouillon and salt is done for 15 minutes. This is followed by shredding, where shredding of the meat is done by passing through perforated plates of 2.5 mm, 4.7 mm or 9 mm plates according to the requirements. The next step is sterilization and dehydration, where sterilization at 1 atmospheric pressure is done prior to drying to reduce microbiological load. Hot air convection dryer is used for drying at 65 degrees Celsius till a final moisture content of 5% is reached. The final packing of the chicken is done in nitrogen flushed aseptic packing to pack meat. These processes are much similar for organ meat from beef, cow, poultry and bull products and chunk style products. In all the products, lower than 10,000 microorganisms per gram is maintained. Talking about the drying conditions and their effects on dehydrated product quality, the heat and the mass transfer rate affects the product quality like texture, appearance, color, flavor, taste and nutritional value. Shrinkage is evident in soft foods rendering porosity. Non-enzymatic browning in proteins and vitamins, the destruction takes place. Thermal damage results in product defects. Minimal retention of organic trace elements in the dried fruits is evident. Sun-dried spices, leaves and herbs are subjected to ionizing radiations. Hygroscopic products should be stored in air-conditioned rooms. The prime factors suitable for packaging and sufficient storage conditions in post-drying handling of all dehydrated products is mandatory. Talking about the rehydration characteristics, parameters that decide the quality of dehydrated foods are rehydration ratio, which is a ratio of rehydrated mass to the original product. Rehydration rate or time indicates the rehydration kinetics. Rehydratability denotes the drying conditions. Porosity is a significant factor for quick rehydration. Leaching is the movement of water-soluble substances into the cooking medium. Finally, let us discuss about the properties of the dehydrated foods. The dehydrated products are analyzed with respect to the following properties. The first one is wettability. The capability of the dehydrated product to absorb water is termed as wettability. Sinkability means during reconstitution, a quantity of powder should sink down to the water rapidly. The next property is dispersibility, where uniform dispersion in water without forming lumps is seen. Agglomeration refers to a product with no lump formation and porosity retention. Solubility indicates the complete dissolving of the dehydrated powders. Let us summarize whatever we have discussed so far. Drying is one of the oldest techniques of food preservation. Dehydration is a process involving heat and mass transfer from the food. In sun drying, sun's radiation is used for drying, whereas solar drying utilizes a convective dryer that heats up the air with solar energy to dry the products. An important pre-drying treatment given to most foods like fruits, vegetables, meat and poultry, etc. is blanching, where the foods are immersed in hot water followed by immediate immersion in cold water. Sun drying and mechanical drying are the different types of drying in which sun's radiation and convective drying techniques are used. Dry fruits of commerce worldwide include raisins, prunes, figs and cut fruits like peaches, prunes, apricots and apples are dried by the sun drying or the dry, blanch and dry method. Washing, grading, trimming, sulfiting, cutting, resulfiting, dehydration, quality grading and packing are the different steps involved in the dehydration of fruits. In fruit and vegetable dehydration, sulfiting is a significant step in reducing the microbial load in the final product. Dehydration of potatoes includes steps like cooking and mashing other than normally followed dehydration steps. Sulfiting is avoided since it causes discoloration in potatoes. Granular meat products are highly demanded all over the world, which mandates a separate operating plant, strict implementation of bylaws and cold storage facility in the premises. Fleshing and deboning followed by mixing, shredding, sterilization and dehydration followed by modified atmospheric packaging are the steps in dehydration of chicken granules. Drying conditions greatly affect the final product's physical quality and rehydration properties. The final quality of the dehydrated product is assessed by properties like wettability, sinkability, dispersibility, agglomeration and solubility. Thus, dehydration process when performed under proper conditions would retain the basic characteristics of the product with highest nutrient retention. Thank you.